Hey everyone, this video is about correlation. This is an extremely common term and it can refer to a few different kinds of things, but in this video we're going to be focusing on bivariate correlation. So what that means is just bivariable, two variables that are correlated with each other. So here's an example of that. We have an x and a y, and it's pretty clear, even just eyeballing it, that there is some kind of relationship between these two variables. There's these two things that tend to go up together or down together. So, if you were to imagine, what is the average level of y in cases where x is at least approximately 0? Well, that's going to be lower, whatever that average is, it's going to be lower than the average where x is 2, right? If you were to find all the people who have an x of about 2, what's their average level of y? That's going to be higher, right? So we capture this idea of two variables kind of coming and going together under the heading of correlation. Here's that same figure again, but we can tell by comparison with this figure that the one on the left is quite a lot weaker in terms of the association, right? Compared with the one on the right, or in the center of the screen, the one on the left looks like, I don't know, maybe there's something going on there, but it's a lot less clear. So we'd call that a much weaker correlation. Contrast with that, the one on the right, that is a perfect correlation. I mean, literally one-to-one correspondence. The score on x is the score on y. They are equal. There's a perfect one-to-one relationship there. And so what that shows is that correlations can vary in terms of their magnitude. And the highest level of correlation would be 1. A perfect one-to-one correlation, which, by the way, you ain't never going to see in real life. This is simulated data. These are not real. You will never see a relationship that perfect. But you can get pretty close. Now, if you're wondering, we actually can quantify the strength of these kinds of relationships using a correlation coefficient. The coefficient of the correlation is just a number that indicates what you're seeing here, that there's different strengths or magnitudes of correlation, and it's just a number to represent how strongly correlated they are. So for this first figure, that's a 0.5, correlation coefficient of 0.5. Now, the most common one, and the one I'm showing here, is Pearson's R. There are other kinds of correlation coefficients. For instance, there's one called Spearman's Rho, but almost always you're going to see Pearson's R, so that's just what we'll talk about today. Then on the left, this is a correlation of 0.1, and on the right, it's a correlation of 1. Perfect one-to-one correspondence, perfect correlation. Now, if you're wondering, where do these numbers come from? How do you calculate these numbers? There's actually a really lovely video, about 12 minutes long, by Khan Academy, where he walks you through how to actually calculate this by hand. And obviously, in his kind of toy example where you're doing it by hand, it's only a few observations. If you were to try and do that for these figures have 500, that would be incredibly tedious. But I think it's actually really useful to go through at least once, just seeing how this number is generated by hand. It seems a little bit intimidating at first, but it's really not that complicated once you get into it. Now, of course, in addition to these kinds of positive correlations, you can also have negative correlations or inverse correlations. So here we have the exact same magnitude of association, only inverted from what we saw before. So what this tells you is if 1 is the upper bound on a correlation, then negative 1 is the lower bound. All correlation coefficients are somewhere between 1 and negative 1. Here's a real correlation. This is no longer simulated data. These are real data from a real study where I've got self-control. This is a trait measure of self-control, self-reported, and then a self-report measure of perceived meaning in life, basically to what extent do you feel like your life is meaningful. And interestingly, these are actually pretty strongly correlated. Right? This is a correlation of 0.62. Now, it would be kind of rare in a real paper that you'd only have 2 variables. So often if you've got 3, 4, 5 variables, you want to be able to present these kinds of correlations as relationships among the different variables in a nice, concise way. And for that, we have a table like this. This table is presenting the correlations between 3 different variables. So there's those first 2 that we saw before, but now we have a third variable, compassion. And if we wanted to know the correlation between any particular pair of variables, all we have to do is find the column and row with the right numbers. So perceived meaning in life is numbered 1, self-control is numbered 2. So if we go row 1, column 1, row 2, then what we'd find is that 0.62. That's the correlation we saw a moment ago. But if instead we wanted to look at the correlation between self-control and this new third variable, compassion, well, then we would go to column 2, row 3, and that would give us 0.39. So that's the correlation between those two. You'll notice each of these coefficients comes with a pair of bracketed numbers as well. So what are those? These numbers define a so-called confidence interval. Confidence intervals are basically our margins of error. They are the sort of buffer around our estimate for the coefficient that defines a certain region where we think the true coefficient is somewhere in that region. Now, why do we need that buffer in the first place? Well, remind yourself what we're doing when we do statistical tests like this. We are taking a sample from a particular population, and we're trying to make inferences from what we see in that sample to what's going on in the population, right? It's not like we just happen to care a lot about the few hundred people who are involved in this particular study. Instead, what we want to do is try and learn something about people in general from the people who are in the study, right? So what we do is we make this inference that the way things work in the population is probably like the way they work in the sample, but we know that our sample, has a lot of weird random things going on. Probably, if we took another sample, we might get a slightly different estimate of the correlation between these two variables. So we know that this estimate is probably not perfectly accurate. What we want to do, therefore, is define a region and say we are very confident that the true correlation coefficient, whatever it is out in the population, is somewhere in this interval. So our best estimate based off of these data for the correlation between perceived meaning in life and self-control is 0.62, but we know there's some flexibility in there. The true value might be a little bit different, but we think that that true value is very likely somewhere between 0.56 and 0.67.